Welcome to the AgEmerge podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monty Bottens. Thanks for joining us.
Thanks for joining us. Today we welcome Dr. John Tooker. Dr. Tooker is a professor and extension specialist in the Department of Entomology at Pennsylvania State University. We have a great conversation with him as he discusses his research studying the relationships among plants, invertebrate herbivores, and natural enemies to understand the factors that regulate those populations of insects and slugs. Dr. Tooker talks with Monty about how they are helping farmers observe what's happening in, but also around their fields, and using the power of observation and pausing to explore all of the possible factors affecting their system. In addition, the long-term goal of his research is to exploit ecological interactions for sustainable insect pest management. There's a lot to explore, so let's jump right in.
Welcome, everyone, to this episode of the AgEmerge podcast. I'm blessed to be joined by Dr. John Tooker from Pennsylvania State University. He is an entomologist, so that means he loves everything bugs, but in particular, he's interested in all of that connection between plants and our small animal friends, insects. But John, tell us a little bit about yourself, your background, your story. How did you get to where you are today?
Oh, sure, Monty. Thanks for having me on. I'm an entomologist. I get kind of excited about insects and their interactions with each other, their interactions with plants. I got into entomology because it was one of the only classes that I really kind of engaged with in undergraduate. I started learning about things, and I really kind of had a hunger to learn more. And at the time, I didn't know that it was a career. But in a roundabout way, I kind of ended up at the Pennsylvania State University, and it's been lovely for me. I love working here, and the support system's great, colleagues are great, and it's been a really comfortable time where we've been able to do some interesting research that seems to be helping some farmers anyway.
I think you're doing some amazing things, and you really opened my eyes to the impacts of systems-based things that we're doing. So I was at the National No-Till Conference, and I think you or one of your grad students or both were presenting at that time. And it just really jumped out in my mind. And I need to get the photo from you, but you have like a no-till drill that you were driving through a field planting green, I believe, and it was just covered in slugs. I mean, I've never seen something so just make you kind of creepy how much was on there. And you're explaining this problem that we had with slugs. Talk to us about that situation. I mean, we had this going on, and you're trying to discern why do we have this slug problem coming into no-till when we hadn't had it in the past?
Sure. Well, first things first, just to be clear. So slugs aren't insects. A lot of people forget that, and they leave their high school biology or their college biology behind. But slugs are mollusks, and as such, they kind of fall through the cracks. There are very few, if any, departments of malacology in this country.
I can't even spell that. Malacology. Wow.
Malacology, study of mollusks. And those people that do study mollusks are usually studying squids or snails and their shells and their evolutionary relationships among things. They're not usually on the applied side trying to figure out why such animals are problematic. But it is certainly the case that there are a bunch of snail species that are problematic, and then slugs are problematic for certain parts of our country. And that problem that slugs cause seems to be expanding as more people get into no-till, and there are more people in no-till longer. On top of that, certain parts of the country are getting wetter as climate change kind of proceeds. And one of those parts of the world is where we live. So we're in Pennsylvania, which of course is part of the mid-Atlantic states. And the mid-Atlantic states are projected to be far rainier in 5 to 10 years from now than it currently is. And it's rainier now than it was, say, even a decade ago. So more people are finding slugs as a challenge as they move into no-till. So slugs are shellless snails, more or less, and they thrive in stable, moist environments. And that's what no-till fields are. So when I started on the job in 2008, as a naive entomologist, happy to have a faculty position and really the opportunity to do the research that I thought was important, I started getting phone calls from farmers in the state that were asking a lot of questions about slugs. And I had to tell all those folks that I have no idea what you're talking about. Because in entomology grad school, you don't learn about slugs because, again, they're not an insect. So, but it was loud and clear from the farmers that were calling that they had a challenge. So I made a meeting with a small group of farmers. Well, I thought it was going to be small. I thought there was going to be 4 or 5 people there. And this was in east central Pennsylvania, over near a town called Lewisburg. And I walked into a local restaurant there, and there were 30 farmers sitting there. And somewhere in my office, I have a list of all those farmers that were there. And I must say that the list seems to be gaining members because I encounter people all the time who say, I was at that original slug meeting. And they probably were. Maybe they just forgot to sign the list or something. But the scale of the problem really emerged in my eyes during that meeting when all these guys were, and a couple ladies were expressing their frustration with slugs, because the problem is there's very few commercially available options for slug control, and the options that are available are expensive or untested, perhaps even unreliable. So I naively said, hey, I'll start working on that, and was able to recruit a student or two that's been interested. And now we're at the point where we have the kind of clear recommendations that farmers can implement should they be having slug problems, whether that's in the mid-Atlantic states or in places a little bit farther afield. So I get calls from Indiana, Illinois, Iowa, as folks that move into no-till. They might have enough moisture, and they might be adjacent to a waterway, areas that hold more moisture that do start to get slug populations accumulated.
So I think, you no-till, and then plus with the evolution of more and more cover crops, that tends to help the moisture levels also be more stable. So when you change one thing, you change everything, correct, in the system. So you got to looking at that. But so going down this story a little bit further, you being the entomologist, you realize that everything in nature is food for something else, and you're trying to figure out, well, why is this slug a problem? Yeah, no-till, we've changed the environment, but what are their natural controls, right? What are those insects or other predators of slugs, birds and those kind of things? What are they? Why aren't they keeping up with this shift? And talk to us a little bit about how you're trying to discover the connections there.
Yeah, no, that's exactly right. So, as one goes through graduate school, you're kind of trained to understand what you're looking at. And so when I hear about an animal that is kind of running roughshod over fields, my natural instinct is that something's missing. There's a control mechanism that isn't implemented for some reason. I mean, the same reason that, if you have say in your backyard and garlic mustard is taking over, or dandelions are taking over, there's something not eating those seeds or not eating those plants. So the same exact thing entered my mind when I started thinking about these slugs. If the plants can't defend themselves, the other line of defense is having something eating the slugs. So we started looking into that. So the first step was awfully simple. The first student I had willing to work on slugs was a real intelligent scientist named Maggie Douglas. And Maggie and I started asking, what eats slugs? So we started exploring crop fields looking for the animals that might eat slugs. And we quickly found that ground beetles, which are commonly called carabid beetles also, but most people just call them ground beetles. Ground beetles and some other things will eat slugs. We also found that wolf spiders will eat slugs. They're not enthusiastic consumers of slugs, but they're out there. We also found that soldier beetle larvae, firefly larvae, those types of things will eat slugs. And we started to experiment with them. And it was pretty clear And I say experiment, it's pretty basic stuff. You get a slug, you put it in a container with a ground beetle, and you see if it eats it. It's not, we're not splitting the atom here. It's not really highbrow research. But it was pretty clear that ground beetles had a taste, and certain species of ground beetles had a taste for slugs, and they would eat them if given the opportunity. And then we had a twist during that that research that Maggie was doing. She was the hands-on portion, and she just came and talked to me occasionally, and so she gets full credit for all this stuff. We thought it would be wise to have a plant in the assay. So we had these more or less like a quart container that you might buy yogurt in, that we filled partially with soil, and we had slugs running around in there and through the carabid beetles. But Maggie said, yeah, we should put some realism in there and see if those carabids can protect a plant that's growing there from slugs. And so happens that she chose some soybeans from our refrigerator that had neonicotinoid insecticides coated on the seed. And then slugs were feeding on those plants, and then the beetles were feeding on those slugs. And she came back the next day and said, all the beetles are dead. And I was like, what are you talking about? So it's one of these things. I mean, like a lot of scientific discoveries are kind of stumbled into. So Maggie found that ground beetles feeding on slugs that were feeding on soybeans grown from a coated seed, so a seed that had an insecticide coated on it. Those ground beetles didn't fare so well, but when we didn't have the insecticide in the system, they did. And that was a jumping off point for kind of Maggie's whole PhD thesis. And so she studied that, and the next important step was a large field experiment that we did, and we saw a very similar result. So we found that slugs did better in field plots where we grew soybeans and corn with the insecticides coated on the seed. So again, these are the neonicotinoid insecticides. I usually call them Neonics so I don't get tongue twisted. But when Neonics are on the seed, slugs do better. And through a kind of this kind of full field experiment and some lab assays, Maggie figured out that those insecticides are getting from the plant to the slugs, passing through the slugs to the ground beetles that like to eat slugs, and then killing or poisoning those ground beetles. And that essentially releases the slugs from control. So then they don't have as many natural enemies around, nothing's eating them, their populations are kind of free to grow, and they're kind of free to feed unbothered.
And I think that's an important point. What you're talking about is a couple things there. First off, knowing that a slug is a mollusk. So an insecticide is not a molluscicide, I guess I pronounce that. So it has no activity on there. And I think a lot of farmers may be a little confused and think sometimes they apply a fungicide for a bacterial wilt. That doesn't work. And adding more insecticides or more seed treatments to try to control slugs, that's not going to work. If anything, it's going to do the opposite effect, kill more of their predators. So I think that's important to be aware of that. And I think the other thing that you said early on there that's really, really important is when you have a problem, isn't it kind of seem like, and it's maybe we've been biased, or as a farmer myself, into the retail model of if you have a problem, kill it, right? There's always something to, and Dwayne Beck, a friend of mine, he calls it whack-a-mole farming. You have this problem, you get out that hammer and you hit it, and you're trying to constantly kill things, where you and Maggie and your entire team, a research scientist, take a step back and say, why is this happening? So something's happening, not keep it in control. How do you avoid that? Any tips for farmers on how to do that more often versus just make the call and try to kill something? How do you adjust your system? How do you encourage guys to do that?
Yeah, so I sympathize with farmers a great deal because they are typically in a tough position. Like they see something happening in their field, they know that their productivity would be negatively influenced by that problem. They need to make a short-term decision.
You got to fix it now, but and then you also have to figure out how to not do it again in the future, right? Correct.
But as research scientists, we're in a better position to ask kind of those longer term questions. Like so it took a full year for Maggie to kind of ask these questions, set up the experiments and implement them, to get the information back from those experiments, analyze the results, and then draw some conclusions. So a lot of farmers just aren't in a position to have that type of time, right? So it's difficult to advise farmers on how to how to find the time or how to respond to a problem differently. But I've experienced the same thing, that I got a problem. What can I spray? And in my experience, it's the farmers that are already committed to conservation agriculture, either by doing no-till cover crops that include diverse rotations that include cover crops and all that, that will pause and say, and what part of the system is out of whack that this particular problem is happening? And then they'll have the patience, I guess, to not call the chemical person. I mean, so we stumbled into this problem with slugs because of that kind of discovery that Maggie had one day in the lab. But if I was more strategic, or I don't know, more of a forward thinker, I would love to like to say that maybe I could have designed slugs to be a problem, because they're a nice kind of end around to get people to think about their insecticide use. Frankly speaking, I never had that thought until after it happened. But slugs have been great as a problem in terms of my extension responsibilities, because it allows me to talk to farmers about what kills what. Since there are so few slug control products on the market, I can have that conversation about using integrated pest management, or IPM, trying to use less insecticides, because that's going to help your slug problem go away. Whereas if you're always out front with insecticides, you're going to farm your slug problem. You're going to create more of it. So it's just been a nice entry point to talk to folks about moderating their insecticide use.
So let's talk a little bit about neonics. And again, you're an entomologist, right? So you had to stretch yourself into being a muscologist, or I'm already proud, molluscologist. I've already screwed it up. I'm sorry. So, but now we got to go into chemical engineering too at the same time. So talk to us a little bit about neonics. When they came out, it's like, boy, this is safe. It just affects nervous systems of insects. It's easy for handling. We can use it on seed treatments, very low rates, all those things. And just like, it seems like over time we learn that, oh, wait a minute, this is really persistent in the soil. It's persistent throughout the plant. And even the high doses can be persistent into the seed that we're harvesting. And if we turn that into various processed foods, it can be present in there. It's what is that? The unintended consequences sometimes creep up and get us. I mean, talk to us about this class of insecticides. And Europe has, I believe, outlawed them, or some countries in Europe have. What is this chemistry, and why was something that's so great now is looking so bad, if you will?
Sure. Well, that's a lot to unpack there. So there'd be a lot to talk about. So the neonicotinoids, if you took some classic language studies back in high school or college, you'll notice in that wording that neo, of course, means new. Nicotinoid means nicotine-like products. So these are the new nicotine-like products. Nicotine originally evolved in tobacco and a few other plants as a defense against insects and pathogens. And so the idea with neonicotinoids was to find something like nicotine that we could use kind of more broadly. And so some really smart, talented chemists developed the chemistries, and they saw that some of these things are super toxic. So imidacloprid, which was the first neonicotinoid on the market, is 10,000 times more toxic than nicotine. And as a researcher at Penn State, if I wanted to study nicotine and handle it in my lab, I would need special training and a special container to hold it in. So there's a lot of restrictions around that. Yet these things are far more toxic, and people often just handle the seed with their bare hands. That said, they are kind of more specific than many previous classes of chemistry. So they are more narrowly toxic, and that's a good thing. So kind of in the world of IPM and insecticides, the more specific you can make a toxin, the better. So organochlorines, organophosphates, carbamate insecticides are broadly toxic to a wide range of animals. They're all nerve toxins, and they can cause sickness for you and me if we handle them. Neonics are less so. So they're far less toxic to mammals than those previous classes of insecticides. And they're awfully good at killing insects, but they don't only kill insects. They kill some insect relatives. So they're toxic to things called springtails. They're kind of mild, and springtails are involved in decomposition in crop fields. They're kind of mild on spiders and mites, and that's a good thing. They also seem to have some level of toxicity against birds, which is unexpected. They have some toxicity against fishes, which is unexpected. So we don't know the full story. There are a few studies that show that they are toxic to some mammals, just not through the typical kind of nerve-based systems. I don't know a lot about that realm because I haven't really done any research there, but it's safe to say that neonics aren't the silver bullet that they were supposed to be. So there are some downsides to them. One of their main downsides, which was strongly overlooked in the regulatory process, is how water soluble they are. So these things work when coated on seeds because they're water soluble. That means that they dissolve in water and they can be taken up by plants and run through the vasculature of the plant, protecting them for a little while. But that same water solubility means that they can be carried away from the field. So plenty of farmers have reported that they are getting wireworm troubles after they've gotten a lot of rain shortly after planting. That's because the insecticide is moved out of the root zone. It's just washed away. So that leaves their seeds and their seedlings subject to damage by things like wireworm or seed corn maggot or something like that. But that conversation usually stops there. Like, I'm not getting protection. And few people have considered, well, where did those insecticides go? Well, they're carried away with water, and they'll end up in the local stream, and that stream is carried to a river, and that river is carried to a larger body of water. So these things are pervasive in the environment, and they're causing harm in those aquatic habitats. And there is some evidence that in this area, they're being carried down local rivers and streams, and they get into the Chesapeake Bay, and they're causing some challenge to Chesapeake Bay because crustaceans that live in the Chesapeake Bay, like blue crabs, are susceptible to some of these insecticides at various doses and various contexts. So there are downstream effects of using these things locally.
We're taking a short break to share that the AgEmerge podcast is brought to you by the team at Ag Solutions Network. Rooted in innovation, ASN is committed to leaving the land better than we found it, not simply maintaining it. We're here to help you navigate the balancing act of productivity and building a legacy. From practices to products, ASN is more than a new jug. It's a new way of thinking. So don't be afraid to be different. Be afraid to be the same. Contact Ag Solutions Network today at asn.farm. And now, back to our show.
In addition to that water solubility component, there's also a persistence component to it, a half-life component. And I found it kind of interesting that sunflowers, for example, planted 10 years in a field that after a neonic had been used, can still find that chemistry, in the flower itself, which can affect the pollinators that then come to those. Are you aware of that? It's a pretty persistent product too.
Yeah, but it's not as straightforward as that. And the persistence has a lot of us scratching our heads. It has a lot to do with soil, water, and soil binding properties, and how these molecules relate to different types of soil, whether it's a clay particle or a sand particle. But it certainly is the case that depending on the active ingredient of neonicotinoid and the soil type and the amount of rain a certain area receives, that there have been half-lives of neonics reported as 7 days or 7,000 days. And obviously 7,000 divided by 365 is a big number, so that's a lot of years. So yeah, these insecticides can be detected in some soils and under some conditions for a long time. It is also the case that plants can pull the insecticides out of the soil, and so those insecticides would be in the plant, and perhaps that's a good thing. So maybe a cover crop can pull the insecticide out of the soil, and since insects don't generally feed on those cover crops very much, maybe that's a good thing and can be used as a mitigation factor.
Yeah, or to accelerate the decomposition or detoxification of the farm, correct?
Yeah, correct. So we've had that idea and explored it, and they don't pull up enough to make a difference because most of the insecticide is run out of the field in the spring after you plant your cash crop. So when you put your cover crop in the ground in the fall, there's not enough neonic there that the cover crop pulling some out can make that much of a difference. But there are a lot of kind of peculiarities about this neonic that remains in the soil. There's usually a pulse that occurs that comes out of crop fields in late winter in the spring with that snow thaw, the winter thaw that happens. And of course, that wouldn't occur in places that don't get snow, but in the northern part of the country and into Canada, that's a big pulse of neonics that comes out with the ice and snow thaw. And it seems to be, and I don't know much about this, so I'm getting on thin ice, and that wasn't an intended pun, but I guess it's there. Is that something about the freezing and thawing of the soil allows those it seems that the freezing and the thawing of the soil allows the neonic to escape in that time of year. But because it's occurring in that time of year, that's just more evidence that it remains in the soil, and the factors that allow it to stay there or be pulled out are not entirely clear.
So there's lots of, I wanted to kind of go down this road a little bit so that, people listening and farmers in particular know that, hey, there's lots of issues here. Now, these neonics are sold a lot under brand names. And if you want to know what those brand names are, we're happy to discuss those with you offline because they have registered trademarks and lots of those kind of things. So feel free to reach out to us and we'll let you know what those brand names are. Either sometimes they're the chemical manufacturer or the seed company has packaged it with several other items together and have their own brand name there. So we will certainly let you know what those are so that if you want to choose to do something without these neonics in your seed treatment. And, as far as it's pretty straightforward when you're in an insecticide spray. But, I think one other thing is it's also tempting for farmers to do is, hey, you're doing your post-press of herbicide, right? Or you're doing your fungicide application. You know what? Just for a couple bucks, you can add an insecticide to that, and kind of knock down any problems you might have, right? You want to just add that today? That conversation happens a lot. Oh, it's just a couple bucks. How does that? I mean, that's something back to good IPM. We should never be pushing that button, correct? Unless you have the problem. It's not just added as a prophylactic treatment, correct?
Correct. That's my stance 100%. And the earlier in the season that you put that unnecessary spray on, the more trouble it causes. So if it's a pre-emergence herbicide application and you're putting that insecticide in there because you may have black cutworm or you may have true armyworm and you're just trying to avoid that, that tends to cause disruption because you're not putting that insecticide on typically timed to the arrival of black cutworm or when the risk level is, or if true armyworms are in your field. You're putting that on when it's convenient for you because it's the pre-emergence herbicide that, like the weeds, are always going to be there. So that herbicide application doesn't need to be timed as tightly as an insecticide application. These insecticides, and those are typically pyrethroids that are going on that time of year, have a working time of 7 to 10 days maximum, right? So, but if you get some rain in there, it'll be less. You can use surfactants to make them a little bit more water fast, but generally 7 to 10 days is the maximum you're going to get out of that. So if black cutworms arrive later, then 10 days or 7 days, same with black cutworm, then that's not going to have any efficacy, but it certainly is going to kill any natural enemies like ground beetles that are running around the fields that time of the year. And so most of that application is going to hit bare soil where these insects are kind of running around. The same is also true in the post-emergence herbicide applications when you're typically spraying before the canopy closes. So a lot of that insecticide is going to miss plants and go to the ground. where they'll have this short-term activity, but can be negative activity as well. And in fact, there's research that came out of Australia that showed that the same effect that we saw with neonics and slugs happens with broadcast applications of insecticide, whether it be an organophosphate or a pyrethroid, through the same mechanism. So if you're putting out an insecticide and it's killing natural enemies, you can have a slug outbreak just through that broadcast application. It doesn't have to be a seed treatment. It's the same mechanism, just the application of the insecticide is different because you're spraying it rather than having it on the seed, but the same effect happens. So the bottom line is those insecticide applications, as you just suggested, are disruptive. Later in the season, and I know there's a popularity now of putting fungicides out on corn later in the season when it's pretty tall. And sometimes folks are putting their insecticides in there also. That can be killing animals that are occurring in the canopy. But one positive way to look at that scenario is a lot of that insecticide is not getting to the kind of the ground where a lot of these ground-dwelling predators reside. Certainly those insecticides would be taking out lady beetles or lacewings or predaceous bugs that are rolling around in the canopy, and that's not good. But in terms of protecting kind of soil quality, soil health, not getting the insecticides on the ground is a good thing in my mind.
And then, just to put the icing on the cake here, so we're selecting for slugs, and we're having all these other issues with the early treatments, whether it's seed or early sprays. But you mentioned in there too the decomposition. They certain springtails that are really key on residue decomposition. What do no-tillers complain about today?
Too much residue.
That's right. And so part of it's BT driven, part of it's yield driven, but part of it's, hey, we're killing all of our guys that are supposed to work for us. So
yeah, that's exactly right. And just on that note, so one of my recent students, scientist named Kirsten Pearson's found that these neonics limit collembolans, and this could be influencing two things. One, it could be making slugs happier, because if you have more residue that's hanging out longer, fewer collembolans mean that your slugs might be happier. The other thing is just having more residue on the fields, and that can cause challenges, just kind of logistical challenges. So having fewer collembolans is never a good thing. And actually, maybe I'll add a third, is those collembolans, those little bitty springtails, they look like popcorn and flopping around on the ground if you see them, because there can be so many of them and they're just kind of hopping like crazy. Those things provide an alternative food source from predators that might be waiting for a slug to show up or waiting for a caterpillar to come along. Those ground beetles will happily snack on the popcorn that is collembola, or soil mites or things like that in the interim while they're waiting for something bigger and juicier. I mean, it's just like a lion might want to take down a large mammal on the plains of Africa, but in the meantime, they'll be happy eating like a raccoon type thing or something a little bit smaller.
So to keep the ground beetles happy, we have to have the springtails for the salad while we're waiting for the main entree to come, is what you're saying.
You got it right.
All right. Sounds good. Or maybe even the dessert. That's the main course, and the dessert is the slugs. So, All right. So we've pointed out a lot of these issues, and a lot of these interconnectedness and such. So, there's a reason why we started using these insecticides. We had problems with wireworms. We had problems with seed corn maggot. We had all these secondary, right? That's pests. And, I remember in no-till digging those up, and you'd see the hole right through a seed of corn that was planted in the ground. So how do we learn to farm without them again? And let's talk about that importance of rotation. And maybe if a person is in a high value corn bean rotation, how do we maybe induce a rotation with cover crops, or what are some things that we can do to basically farm without these, and not only not farm naked in the case of being in no-till, but also farm with naked seed? What have been some effective things you've seen, guys that have seen the aha and they're tired of fighting nature, they want to work with nature? How do you coach them to do that?
Well, what I typically do is I encourage them to look at the areas beyond their farm. Just look at the forests here in Pennsylvania. If you're in the Midwest, look at the roadsides where prairie remnants are occurring, and look at those areas and ask yourself, are they decimated by plant feeding insects? And the answer is usually no. So then you ask yourself, what's happening there? Why aren't the forests of Pennsylvania or the prairies of Illinois being decimated by insect pests? And that's because There are things eating other things, and the plants have a capacity to defend themselves. So using that jumping off point, it usually isn't a stretch to get farmers to believe that they could farm that type of interaction in their crop fields. And you just mentioned crop rotation. Crop rotation is a key part of this. The worst insect pest challenges that I've encountered are in continuous corn. When you grow the same thing year after year after year, insects and slugs become able to rely on it. Like they don't have to guess. They can just, their populations can build. You might knock them back a little bit with an insecticide, but that is a happy place for them to be. So by diversifying, by putting say a soybean in that rotation, you make their life a little bit difficult. By putting a wheat in that rotation, you make their life even more difficult. If you had a rotation, an economical rotation that was 10 years long, you would not suffer very much from insect and slug pests at all. So the more you diversify, the better, because that rotation is breaking up their life cycle, making their life difficult. By making things more diverse, you also attract more natural enemies. Natural enemies come when there's things to eat. So this concept can make some farmers uncomfortable, but when you start to farm no-till, you tend to have more animals in the field. That's because that stability provides a happy place for slugs, caterpillars, other things. That's kind of a necessary first step to then make the next trophic level, which is just the next layer up of animals that like to eat things, to make that next trophic level happy. So to have ground beetles, to have spiders abundant in your field, you need to have some level of things that are feeding on plants. It's just how the world works. If you can't have lions unless you have gazelles and things like that, right? And that makes some people uncomfortable because, as we talked about earlier, there's this instinct that let's kill what's in our fields. But diversity and rotations allow more herbivores to be in the field. If you just trust the system, natural enemies will come. And those natural enemies are then your allies in pest control. Believe it or not, cover crops make this system work even better because a cover crop is just more habitat in my eyes. So there's more places for natural enemies to forage. There's more places for little insects to be feeding on that cover crop or to be living amongst the roots, and then that's food for natural enemies. So what I encourage farmers to do is look to nature as their guide and then diversify their system as best they can within the confines of the economic production system that they've developed. If they can only be profitable growing continuous corn, well, there's a burden that comes with that, and I can't help that. Then they're going to be investing a lot in BT corn varieties. They'll probably be investing a lot in insecticides over the top of that seed, and they might be doing other things to help maintain lower insect pest population. If farmers are willing to diversify, including cover crops, then they can get away from that mindset and they can actually start to farm their own solution.
So I think that's interesting about looking at the cover crops as essentially a food source or a habitat for, higher level insects that are going to be your friends, your predatory insects, predatory mites, lacewings, those kind of things. So we've had really good luck with that in California on almonds. So we work with our growers there. We plant cover crop species in there that attract these things. So we've had first year, farmers go from 4 miticide applications to maybe 1. And then the more you can pull that out of there, then the next year your populations continue to grow. So it's kind of this transition period, right? You have to maintain economic viability, but you're trying to do everything you can to not pull that trigger. And then the other thing is it does take a little bit of patience too, because as those beneficial populations are growing, they grow after the pest population grows. So there's a lead lag to it.
Yeah.
And you have to be patient enough to not be like, oh, we're at mite threshold, hit the button, because you not only have to scout for mites as an example, you also have to scout for their predators and monitor their increase, because several times, our PCAs there will say, hey, just wait, just wait a few more days and see what happens. And lo and behold, hey, the predator populations are up. The pest pressure has leveled, And we know when that happens, we're going to be on the down curve soon. So it does require some patience and white knuckling, doesn't it, at first?
It does. But I'll also point out that in this kind of type of farming, this sort of farming, I'm not advocating for totally avoiding insecticides. Every once in a while, there's a problem that needs to be solved. Natural enemies aren't doing their job. Let's pull the trigger, as you said. So that's where integrated pest management comes in. So with integrated pest management, we know how much damage crops can sustain from certain pest species. So if those economic thresholds are exceeded, then we know it makes economic sense to apply that insecticide and stop that problem from happening. But one of the kind of tenets of IPM is to let the natural enemies do their thing. So they're the first line of defense, along with cultural practices you might be able to do. They're the first line of defense. So the more you spray, the more you're going to disrupt that first line of defense. So it really is do all you can to avoid it. If you need it, it's there. If you do need to spray something, let's use the most narrowly focused insecticide we can. So like, for example, there are growth regulator insecticides that are very good against caterpillars. So if you have a caterpillar problem, say black cutworm or true armyworm, let's spray something called methoxyfenicide, which is a caterpillar-specific growth regulator that does just as well as a pyrethroid on those two pest species. Let's use that because that's not going to influence your natural enemy populations. So there are some examples like that across the kind of the spectrum of insecticides that are available, where you can be very, very specific based on the problem that you're dealing with. So that IPM is this backup plan that allows natural enemies to be effective.
And that's a great point right there. I suffer from armyworm problems myself occasionally, where I have a wheat that I take for grain or rye that I take for grain ahead of a crop. We'll get volunteer regrowth that happens early enough that then we get the flight, laying eggs in that green mat, because the greenness is there when they're coming through. And it's like the only field around that has it. So it's a heyday for laying. And then the next spring, we have, the armyworm issues. So the button has always been the pyrethroid, because that's what everybody stocks and everybody knows it's cheap, and that's the way you go. But in that situation, like you're saying, you spray it, then you're likely inducing other problems of other pests, whether it's slugs or anything else, to come in and creep up later on. So it's a cycle. What we're trying to do is stop the problem of the volunteer in order to not create the habitat to get the egg laying, and
Sure.
But the growth regulation, that's a great alternative, and to think of that. So I know you've been doing a lot of work in Pennsylvania on planting green, because like you said, the frequency of rains and the intensity of rains continues to increase. I'm facing that even here in Western Illinois. And I think that's definitely an alternative. We almost need to grow these big crops in order to float across the field to plant. Tell us about some of your experiences in that. You've done some great work on that, and your team, and what you're seeing there, and beneficial shifts.
Yeah. So planting green is something that farmers that I've interacted with have been doing for decades. There's some kind of old timers kind of stumbled into it because they're always late with their cover crops. They adopted cover crops early in their farming life, and they, whatever reason, they didn't kill the cover crop really enough. So they just said, oh, heck, I'll plant. And they started to see some benefits from that. But within the last, I don't know, 7 years or so, 7 to 10 years, there's been a rejuvenated interest in planting green, because folks want to keep their soil covered all the time, and they want to benefit from the greater amounts of biomass that their cover crops can produce. We started studying planting green because it looks, well, initially I had a collaboration with a farmer friend of mine, and he wanted to give it a shot. And I was looking for a couple ways to control slugs. One of those ways is to distract them, giving them an alternative food source. The other detail that we knew is that if you diversify a crop field, just by increasing the crop species in the field from 1 to 2, you increase the number of insects in that field. And along with that comes more natural enemy.
So just not to interrupt there, but from 1 to 2, how much of a difference does that make in the insect species? Just that simple change. It's more than 2 times.
Well, so in our research, that first year we did it, we found 3 times as many ground beetles in plots that had soybeans and cereal rye planted side by side than we had just soybeans by itself or corn by itself. So I don't know if there's a linear relationship there, but it's certainly an increase, and it will depend on the combination. But this collaborator of mine who lives down the street, this guy Lucas Criswell, who is known in some no-till cover cropping circles, he was instrumental to getting me kind of started in this slug world. He still claims credit. He says I owe him like $1 million or something like that, but I haven't made $1 million, so I can't give away $1 million. But Lucas and I kind of came up with this idea together. Staring ahead at his fields that were suffering from slugs, and then thinking about what I could experiment with. So we started planting cover crops between rows of corn or soybeans. And then those results were fairly promising. So we saw that if you had corn or soybeans interseeded with cereal rye in the spring, that you cut the amount of damage to your cash crop by half, and you tripled the number of ground beetles. So we got those results in the summer, and then that fall, Lucas went and planted like 200 or 300 acres green. Like, he just went and did it. And I wasn't comfortable enough to say, that's a good idea, Lucas. I was like, oh, that kind of is worrisome. But it worked out. And so he continued to do that. And then like a year or 2 later, he invested in rollers on the front of each row unit. And he was doing that, and he was talking to some of his farmer neighbors and farmer buddies about doing that, and they started doing that. And I thought, man, the cow's out of the barn here. Like, we don't know enough about this to really be supportive. So we then got a research project in place to kind of backfill the information that we needed to be more comfortable with this idea. And we have since found, through a couple graduate students' efforts and a couple postdoctoral scientists that have worked with me, that planting green has 2 benefits for slug control. And it's the 2 I've already outlined. It's one, that they are planting green distracts slugs from the cash crop because they like to feed on cereal rye in particular. And it's a better habitat for natural enemies. But at the same time, I've heard of farmers that have done this, but kept their same insecticide program, and they've just had a mess on their hands. So they're, in my mind, planting green will have the best effect against slugs if you get away from typical insecticide use. So that's a key piece that is often overlooked. People just enthusiastically just start planting green, but they still have the insecticide coat on the seed, and they still are putting an insecticide out with their burn down or with a post-emergent spray. And that just creates a situation where the slugs are going to win, because there's no predators for them to fear, and there's plenty of food. They have a cover crop to eat. And if they're really done with that, they can go over to the cash crop and they can just go to town. But our research is showing that actually the bottom-up effect of that distraction of having something else in the field is just as, if not more important in some cases than the predators. But in my mind, they're kind of 50-50 contributors. But in some situations, just that distraction alone is enough to get the cash crop out of the ground and growing well and have a successful crop year.
Well, there's a lot to unpack right there. First off, I want to thank you and Lucas and all the other farmers, because, them diving in and getting it done, and then you following along to follow what they're doing. I think that's so valuable, because they're dedicated to making it work, and farmers are artisans, and they know their fields the best, and they do it. But the nice part is you jumping in with your team quantifies what's going on. And I really think kind of that public partner research that you're doing right there is wonderful. It's real world, real application. I love that approach. The other thing is, I could just kind of hear that big gulp that a lot of our growers were taking when you said, okay, wait a minute, you're telling me to plant green into this jungle, and you're telling me to not use any insecticide and not use any seed treatments? Are you nuts? I could just hear it like, oh man. I mean, that's a jump, right? So we would tend to think that, with that jungle, we've got a bigger problem. We really need this stuff. So what you're saying is that makes it even worse. So if you're gonna jump off the goofy and you're saying just just go all the way, huh?
Well, yeah, but I think it's worth emphasizing that we didn't come to this point in our thinking just based on speculation. Like we
Right.
did the experiment and we kind of built up the pieces, working with Lucas and some other farmers out there, a guy named Jim Harbaugh, a farmer named Joe Anker. We've worked with these folks on their property and kind of figured this out. And we've come to the conclusion that, yeah, having the insecticide there doesn't help. It's not controlling much. And it is a hindrance in a way that it will restrict the natural honey populations. And one thing we haven't touched upon, Monty, is that people give the neonics more credit than they should be given. So colleagues at Purdue University, particularly a guy named Christian Krupke, has measured the amount of neonics left in corn plants at various points after planting. And it's difficult to detect neonic in that corn plant after 10 days. It's certainly undetectable after 14. But so you're getting maximum 10 to 14 days of protection from that insecticide. And sure, that protection is when the plant is most vulnerable, but the concentrations of the insecticide in the plant are the highest just after germination. 10 days later, they are a fraction of that, a tenth of that, a 20th of that. Christian has all the numbers, but there's this negative logarithmic relationship between the titers in the plant. So I guess my point in raising all this is that farmers are getting far less protection than they're expecting from these miracle chemicals that are coated on the seeds that are going to provide this protection. I mean, a lot of the company marketing material says you get 45 to 60 days of protection. Well, that's horse manure. You're getting far closer to 10 than you are to 60. I mean, that's ludicrous. Anyway, my point is that in raising this issue is that it's less of a jump than you might believe when you think of the actual control you're getting from that insecticide. If you put it in terms of a pyrethroid, again, that's 7 to 10 days maximum. So it's not like you have this invincibility cloak thrown over your crop and that's to protect from everything just because you use an insecticide. The window of control is awfully narrow compared to the length of the growing season. Like if you're growing 105-day corn, right? So sure, maybe you take 10 days out of that. You got 95 days that you're getting nothing out of that insecticide when it's coated on the seed. Does that make sense?
Absolutely, it does. And I think the bottom line, anybody listening, you need to try some naked seed. That's all there is to it. Or stuff, there's some biological, controls that you can get that are organic approved. But yeah, get away from it. It's not doing you much of any good. And diversify your system to where you don't have that problem. I think that's, you don't do it on your whole farm, but try it. See what you got going on.
Monty,
we've got all naked seed and have not had any problems. So
I'm sorry to interrupt. Can I make two more points?
Sure.
One is that we need to, the first point is that, yes, try it on a small scale, just as you said. Try a 20-acre field and see if that works for you, then grow from there. But you need to be patient with it. So studies have shown that ground beetle populations won't return to their maximum until 3 to 5 years after you stop using those treated seeds. So it's not going to be immediate. But in that transition, you have IPM as your backup plan. So you'll be able to apply insecticides if something goes wrong, if the predators don't come quickly enough. So IPM is kind of your crutch in all this. The other point to recognize is that the seed industry isn't really helping us very much in this realm because treated seed is the norm. Finding untreated seed or uncoated seed or seed that's free of insecticide can be challenging. I've talked to growers that they have to pay more to get uncoated seed because, or seed that has fungicide but no insecticide, because that is out of the typical production system. And the company has to go and pull some units to make that happen. But it's worth pointing out that there are regional or local seed companies that are happy to provide uncoated seeds when the national companies can't. So there's a lot of Pennsylvania local companies that love the message I'm giving because it's providing them an opportunity to connect better with local growers, and they often are at a disadvantage when it comes to competing for farmers' seed business because the large companies dominate the marketplace. But this little niche opportunity is pretty good for local companies that are able to exploit it.
John, are you aware of any directory or resource out there where a farmer can log on and find find a seed that is untreated, that is kept up to date or things like that?
No, I am not. As far as I can tell, it's just legwork and knowing your local options.
So guess what you and I need to do?
Do that.
Yeah.
Maybe-
Yeah.
maybe-
I think that'd be fun. We could, it wouldn't be, honestly, it wouldn't be that hard to do. And I think that'd be a good resource for people to help them maybe. And, but I think if you're calling around all the seed companies and say, hey, we're creating this directory and this is really important, might change some of the bigger players, so.
Well, I've had these conversations with representatives of those bigger companies, and they don't seem interested. They've set up their production systems a certain way, and it allows to treat a lot of stuff quickly. And I don't think they'd like to lose that investment.
It creates a lot more SKUs for them. That's all. You've got enough SKUs, stock keeping units as it is with the hybrid and all the different seed plate sizes, lot codes, and everything. Yeah. Now, if you got it with and without seed treatment, you've just doubled everything.
Oh, so yeah. No, it's a logistical challenge, but I can name 5 local companies in Pennsylvania that can provide you uncoated seeds.
Happy to solve your problem.
Yeah, exactly right. So
okay, before we go today, I got to ask you. I was doing a little bit of internet creeping ahead of time here, and I saw some work that you're doing on plant smelling insects. Okay, so that sounds a little strange. What is going on there in this wonderful world where plants and insects are talking to each other?
Okay, Monty. Yeah, you've been digging around. That's good. Part of the joy I get from my job is we can explore things on an applied side that are very relevant for farmers, and other things on the very basic side that are kind of less so. And this is started as a basic science question, because it's well known that plants are opportunists. They can detect things in the environment. So if you have plants in your backyard and you walk around them regularly, those plants will grow differently than similar plants elsewhere in the yard that you don't walk around. So they know you're there. They know when there's a plant next to it. They know they get shading. They know that shading is there, and they change their growth pattern. We also know that insects, when they feed on plants, cause plants to release a different bouquet of odors. So some colleagues and I just asked the question, can plants smell the pheromone of the insects that feed upon them? And we started asking this question in goldenrod, and goldenrod is a native plant in the eastern United States. Well, heck, a large portion of the United States has plants in the genus Solidago. And it happens to get attacked by a fly that makes a lot of pheromone. So we asked the question, can the plant detect that pheromone? And a pheromone, as a reminder, is just a chemical that brings different members of the same species together. So males and females together, for example. You can also bring males, females. These things have multiple functions depending on what type of pheromone it is. But most sex pheromones, it's one sex attracting the opposite sex. In this case, it's the male fly attracting female flies. And so we asked the question simply, can this goldenrod plant detect the pheromone of this fly? And indeed they can. So when we published that a while ago now, that was the first example of a plant smelling an animal. And smelling is a stretch. That's an anthropomorphism, but it's it's a similar idea. We're continuing to study that in goldenrod. I have a couple folks in my lab that are studying that. We're also trying to study it in more applied systems. We're studying it in cranberries with a colleague in Wisconsin, where cranberries are more relevant than Pennsylvania. And we've also looked at it in corn. And we're not sure what we've discovered in corn, but corn is very sensitive. It can smell a lot of things. So we just think it's capable of kind of detecting odors of different things. And if it's weird, they're going to be alerted to it.
So I can imagine how you'd set up the trial to see whether or not the plant can smell the fly. But what are you monitoring? What is the response to the plant? So the plant says, "Oh, there's this pest that likes to eat me coming this way." How does the plant respond as far as, is it different sugar content, different cell wall structure, is it trying to mask itself with the different odors, or what is that plant response? It says, I smell somebody coming to eat me. What does it do?
It changes its chemical status. So it has different chemicals and higher levels of chemicals in its leaves. and those chemicals then deter the feeding by the fly and leaf feeding other leaf feeding insects. So we measure a plant hormone called jasmonic acid, and find that plants that are exposed to the pheromone and then attacked by insects have higher levels of jasmonic acid. Jasmonic acid is a well-known plant signal that induces all these downstream changes, chemical changes. There also can be physical changes, like they might have more trichomes on leaves. Trichomes are little hairs that kind of act like thorns to little bitty animals on leaves. So we measure the amount of feeding damage the plant receives, whether the fly is successful or not, and then we use jasmonic acid as a proxy for all these chemical changes that might be occurring. Did that answer your question?
Yes, it did. And
Okay.
so the thing that's interesting is we've worked with that on some of our biological products that we spray foliar, and we do notice decreases in Japanese beetle silk feeding on corn,
Oh, okay.
decreases in spider mites in western states and those kind of things. So there definitely is a signaling aspect there, and we've never really known why or how it's working. But yes, aromatic acid that you're talking about there is certainly contained in what we're spraying. We just didn't know what we were doing. It's one of those things that you're doing something that works. Like, all right, how do you figure it out? And it's neat to see that you're exploring that.
Yeah, well, they're along those same lines. There are commercially available jasmonic acid products. Maybe you're using some of these that it's known that if you spray them on, say, your cucumbers or your tomatoes, you'll get more trichomes, and that'll help them better defend themselves. Yes, without question.
Right, and that is a big deal. So,
Mhm.
very interesting. What other interesting work that you're doing, or other things you want to share while we're here today?
Oh, wow. Well, at the moment, we're starting to study spiders more, particularly spiders in alfalfa. Try to understand how we can increase spider populations in alfalfa to combat things like potato leafhopper.
And your neck of the
alfalfa
woods,
weevil.
that is after every cutting, people are spraying, and that's a problem. So that's great.
That's true, but there are these farmers that are around that don't spray their alfalfa.
You found some weirdos, and it's working, right?
I don't know if I'd call them weirdos, but I'm thankful that they don't, because then we can kind of talk with them about what they think is happening, and then we can go experiment on that. So it's very similar kind of collaboration that we have going on with these other farmers.
Very, very interesting. So we'll get some. We'll be able to follow up with you in a year or two and find out what the responses are there.
Potentially, it might be longer than that, but yeah.
Okay. Well, I imagine
progress.
There's probably some mixes you could put in that alfalfa versus just straight alfalfa that'd really help, and timing of cutting and those kind of things that would affect all of that.
Yeah, we're looking at different heights of plants, because spiders disperse awfully well despite not having wings. They can put out strands of silk, and they move remarkably well by ballooning, it's called. And so spiders are some of the first things that colonize, say, volcanic islands after an explosion. Spiders are usually the first things there because they disperse so well. So we're just trying to figure out how we can take advantage of that dispersal capability and capture them in fields where we want them. So that's the main thrust of this experiment.
For those that aren't watching on YouTube and listening, it's just fun to watch an entomologist's facial expressions when they start talking about spiders and stuff. They just get all excited. I love entomologists because they're passionate about what they do. And most of us are like, ooh, it's a spider. That's creepy. Get rid of it. So, that's great. And I really appreciate all the work that you've done there, John, with you and your team. And you've just turned out a lot of practical things that have helped a lot of farmers continue to stay in no-till and adopt cover crops versus, throw up their hands, say, hey, this doesn't work. We got to go back to the old ways. So I appreciate all that you've done to really help keep soil health front and center in what we're doing in farming.
All right. Well, thanks for the kind words, and I appreciate the interest in talking with me today. Awesome.
Yeah. And please, if you have more things, we'll try and keep in the loop of what you're up to, but we'd certainly like to revisit some of those things in the future as you learn on plant communication and your alfalfa project and those kind of things. We'd love to follow up again in a few years. So excellent.
All right. Thank you very much.
Thanks for listening to this conversation. What a great example of how pausing to examine our system can really shed light on those relationships between plants and pests. It's exciting work that we will look forward to following. And as always, if you'd like to learn more about what we're doing to help growers implement soil health practices, check out our website at asn.farm, and there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn.